Hello everybody, we are going to try to solve this problem number 4 now. I read it. Three friends, Archie, Billy and Charlie, play a game. At the beginning of the game, each of them has a pile of 2024 pebbles. Archie makes the first move, Billy makes the second, Charlie makes the third, and they continue to make moves in the same order. In each move, the player making the move must choose a positive integer n greater than any previously chosen number by any player, take 2n pebbles from his pile and distribute them equally to the other two players. If a player cannot make a move, the game ends and the player loses the game. Determine all the players who have a strategy such that regardless of how the other two players play, they will not lose the game. Okay, it seems interesting, but obviously not simple. So we shall try to find some strategy. So we have three players. Three players, Archie, Billy and Charlie. And at the beginning, each of them has 2024 pebbles. I shall denote this as n. It will be easier for me to write. Okay, so n is 2024. Okay, maybe m, because n is used in another way in the text. So let me call this m. So m is equal to 2024. So Archie plays first and he chooses a positive integer n, which was not chosen previously. So Archie can choose a 1. After that, Billy, which plays the second, need to choose another number greater than this used previously. So Billy can choose 2. So we shall first try to see what happens if they choose numbers in order 1, 2, 3, 4, 5, 6, and so. And later, then we shall try to see what happens if they choose a bigger number, not just by 1 greater than previous one. So Archie choose 1. So after this move, he will have m minus 2 because he chooses number 1, but chooses 2 times 1, 2 pebbles, and gives 1 pebble to the Billy and 1 to the Charlie, which now have m plus 1 and m plus 1. Okay, now Billy choose number 2, so he distribute 4 of his pebbles. Now he will have minus 4, so m minus 3, and distribute 2 of them to Archie, 2 to Archie, so Archie will have m, and 2 to Charlie, who will have m plus 3. And finally, Charlie choose number 3, so he takes 6 pebbles, which means that Charlie will have m minus 3, and distribute 3 of them to Billy, which will have m, and 3 of them to Archie, who will have m plus 3. So after one complete cycle, one play of Archie, Billy, and Charlie, with choosing those numbers 1, 2, 3, what happens? Billy has the same number of pebbles as at the beginning, m. Archie has 3 more, m plus 3. And Charlie has 3 less, m minus 3. So let's try another cycle. Let's try another cycle. So 4, 5, 6. What happens now? Again is Archie ready to play. Archie now chooses number 4, so which means he takes 8 pebbles, so he will have now minus 8, so m minus 5, and Billy will get 4, which is m plus 4, and Charlie will get 4, which is m plus 1. Now Billy choose number 5, which means that he takes 10 pebbles. He will now have minus 10, which is altogether m minus 6, and distribute 5 to Archie, who will have m, and 5 to Charlie, who will have m plus 6. And finally, Charlie choose number 6. He takes 12 pebbles. He will have now m minus 6. And Billy will get 6, which will be m, and Archie will get 6, which will be m plus 6. So after another cycle, Archie gets 3 more pebbles. Billy is on the same m, and Archie again loses 3 m minus 6. So it seems that Archie will lose the game, but let me see what will happen now. So after one more cycle, here we will have m plus 9. Here we will get m. Here we will have m minus 9. After one more, here we will have m plus 12. Here we will have m. Here we will have m minus 12. And so on, so on. So maybe it's good to write which number is chosen. Here we will choose 1, here we will choose 2, here we will choose 3, and we will have this after 3. This we will have after choosing numbers from 1 to 6, this from numbers to 9, and this from numbers 12. So we will actually get m minus 12 after choosing 12 numbers after 12th place. So we need to find out which is the first number less than 2024, less than this, which is divisible by 3. And so we divide by 3. So this is 6, 2, 7, 1. So 4 and 2 remains. So after 674 cycles, Charlie will go down to only 2 pebbles. This is the rest here. Billy will have again 2024, and Archie will have 2022 more, so 4,046. So after 674 full cycles, we will have this number of, and the number chosen, and the number chosen before that was 2022. And now Archie needs to choose bigger numbers, so Archie needs to choose 2023, and he gets actually the number which is required by 1. So no more, no less. So he chooses this number, and now he has 0 pebbles. Distribute 2022 to Billy. Sorry, 2023 to the Billy, who will have 2000, excuse me, 4000 and 4047. Yes, Archie plays, Billy plays, Charlie plays. This was one for full cycle. And Charlie will get 2023 and it will have 2025. And now actually Billy loses the game because Billy needs 2 times 2024, which is 4048. So he has 1 pebble less, and Billy loses the game this way. So now we will try to see what happens if each of them chooses a number which is not the following number. So if the previous player was chosen some number, let me say n minus 1, and now the second player needs to choose at least n. But what happens if he chooses n plus k? So if he makes a gap of k numbers. And we will try to make a matrix. How that affects that same player, but also other players on their next turn. So we will have Archie, Billy, and Charlie here. Archie, Billy, and Charlie here. And we will try to put in this 3x3 matrix how this strategy by using plus k, n plus k instead of n, which was the minimum that needs to be chosen. So what we achieve with this strategy by using a bigger number, bigger by k. So how this affects that same player and other 2 players. So we need to put in this matrix what happens if Archie uses this strategy, how this affects his play on his next turn, and how that affects other 2 players, and also for Billy and Charlie. So we will need to do this systematic calculation now, but I hope that after that we will have some idea what actually happens. So we can use this at any point. Because after one cycle, Archie just gets +3 and Charlie just gets -3, we can simply without losing generality, see what happens if they choose this strategy and their first moves. So Archie is first here. Um, um, Here, the next after this, this is initial position, distribution of pebbles. After Archie plays, we have this. After Billy plays, we have this, and after Charlie plays, we have this. And now we will see what happens if we choose by K more. So if okay, again we have M initial position. Now instead of 1, Archie chooses number K plus 1. So how this affects the game? So after that, Archie will have M minus 2K minus 2, and Billy will have M plus K plus 1, and Charlie will have M plus K plus 1. Now, okay, we will take a look what happens if other players do not use this strategy now. Just one player, just Archie. So after that, Billy uses number K plus 2. So he now he now needs to take 2K plus 4 pebbles, and it will have M minus K minus 3, and Archie gets K plus 2, which will be M minus K just, and Charlie also gets K plus 2, which will be M plus, which will be M plus which will be M plus 2K plus 3. Okay, so we already can put something in our matrix. This was initial position. Now Archie plays and takes 2 times K plus 1 pebbles. And now it's Billy's turn. It's Billy's turn. And Billy will have at his turn M plus K plus 1 pebbles, and with initial strategy by choosing consecutive numbers he has M plus 1. So this strategy actually helps Billy to have plus K pebbles on his next turn. Okay, now plays Billy and chooses K plus 2. This is this distribution, and after that, Charlie has this number of pebbles, M plus 2K plus 3, and at the initial strategy, by choosing consecutive numbers, Charlie had just M plus 3. So this strategy helped Charlie to get plus 2k pebbles. Okay, and now it's Charlie's turn. Charlie takes k plus Charlie takes k plus 3 pebbles, and so he distributes 2k plus 2k plus 6, and after that Charlie will have m minus 3 pebbles just. Billy gets k plus 3, which is m, and Archie gets k plus 3, which is m plus 3. So after one full cycle, nothing changes. They have just the same amount of pebbles, m plus 3, m minus 3. But the game will be sooner over because they now need to choose higher numbers. They have the same amount of pebbles, but they need to choose higher numbers, so the game will end sooner. But nothing happens, so Archie nothing achieves with number of pebbles. He will have exactly the same number of pebbles on his next turn, so he helps Billy to have plus k, helps Charlie to have plus 2k, and doesn't help himself at all. He will have the same number of pebbles and even will need to choose higher number. So we will see what we can conclude with that, but we now need to do the same for another two players. Now we will have what if Billy takes this strategy. So Billy is on turn after Archie takes number 1, and the number of pebbles will be as here in this second row, m minus 2, m plus 1, m plus 1. And now instead of 2, Billy takes number which is by k greater, so this is k plus this is k plus 2. Instead of 2, Billy chooses k plus 2. So Billy needs to distribute 2k plus 4 pebbles, and it will have minus 2k minus 3. Archie will get k plus 2, which will be exactly m plus k. And Charlie will get k plus 2, will be m plus k plus 3. And now it's Charlie's turn, and he has m plus k plus 3 pebbles. And with initial strategy, Charlie had m plus 3. So this strategy helped Charlie to get plus k pebbles. He has k pebbles more than with initial strategy. So and now it's his turn. Charlie, let's say, doesn't use this strategy. It uses number k plus 3. And so he needs to distribute 2k plus 6, so it will have m minus k minus 3. Billy will get m will get k plus 3. It will have m minus k. And Archie will have m plus 2k plus 3. And so actually, Billy will have now sorry, Archie will have this number. It's his term, and he has 2k pebbles more. With initial strategy, it had m plus 3 here, and now it has plus k. So this strategy helped Billy to get 2k more. And we can guess what happens. Now Archie will take number k plus 4, and it will have m, sorry, um, it will have m m minus 5. Billy will get k plus 4, which will be m plus 4, and Charlie will get k plus 4, which will be m plus 1. As you can see, this is exactly the same as with initial strategy. So nothing changes for Billy, which used that strategy. So we just need to conclude that when one player uses this strategy, it helps the next player to have plus k and helps another player after that to have plus 2k. The similar will happen if Charlie uses this strategy. It will not help him. It will help Archie to has plus k, and it will help Billy to have plus 2k. Okay, that is an idea. But now we need to somehow calculate how this happens, this end of the game, that we will not have this situation, actually this situation, where Billy lost the game, but maybe some another player will lost the game. Maybe some of those players have some strategy. Okay. So if Archie uses this strategy, at his next term he will have the same amount of pebbles, and it will need to choose a number which is by k greater. So it will have to take 2k pebbles. So for sure it doesn't help him at all. Also, if Billy uses this strategy, he will have the same amount of pebbles on his next turn, and he will need at least 2k pebbles more. Also, if Charlie uses this strategy, he will have the same number of pebbles on his next turn, and it will need 2k pebbles more. So on first sight, this is completely confusing because it seems that any player doesn't have a strategy because by choosing higher numbers, the game will end sooner. But so but if Archie uses this strategy, this can be good strategy if it helps him in way that Billy will get out of pebbles sooner, because Billy will get only plus k more pebbles, but will have to choose number which is by k greater, so it will have 2k pebbles more, and it gets just k. So A or Archie can maybe force Billy to lose the game. Of course, Billy is losing the game by our initial strategy also, but if Archie can somehow push other player to lose, he can push Billy. He cannot push Charlie because Charlie, or he can push himself, but he actually he want to push other player before, so he can push Billy because Billy will have plus k and will need 2k pebbles more. Charlie will have plus 2k and will need 2k more, so it will doesn't affect Charlie at all. So each player can affect only the next player after him. Similarly, if Billy uses this strategy, he will not help him at all because it will have the same amount of pebbles and it will need more for his next play. But he can push the next player, Charlie, to lose because Charlie will have only plus k more and will have 2k more to play. And similarly, okay, it seems that Charlie can only affect Archie because Archie will on his next turn have plus k more pebbles and it will need 2k more to play. But also we saw that After one full cycle, the amount of pebbles is exactly the same. So if nobody loses, so if nobody loses, so if nobody loses the game before, but it obviously will, we will have exactly the same situation 4046, 2024, and two pebbles for Archie, Billy, and Charlie. After 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 this number of complete cycles, 674 cycles. And of course, if now Archie needs to uh, choose higher number than 2023, Archie will lose the game. But actually, if they use this strategy, the game will end sooner, I guess. So let me put this like this. So after some L full cycles, let me assume that players played L full cycles. L full cycles. After L full cycles, Archie will have M plus 3 L pebbles. Billy will have again M, which is actually 2024, and Charlie will get M minus 3L. And now let us assume that this is the last full cycle which happened. So L is the largest possible number where all players managed to play. And now we assume that in the next 3 turns somebody will lose the game. So let us see what happens. So if after full cycle they will have the same amount of pebbles no matter of the strategy. So after one full cycle, Archie has +3, Charlie has -3, and Billy has the same number of pebbles regardless of the strategy. The strategy can only help or punish another player in between. After full cycles, they have the same amount of the same amount of the same amount of pebbles, and they need to choose higher number. So okay, so now if it will be initial strategy, Then Archie will need to choose number 3L, of course, 3L plus 1. But they use the strategy. So Archie, they use the strategy and they made a total gap of k. So Archie needs to choose plus some k, 3L plus 1 plus k. Uh, so let me just put at the beginning. Archie had m, then Archie had m plus 3. Then Archie had m plus 6 on his next term, I think, on his next turn, then m plus 9, then m plus 12. So actually, Archie will have on his play m plus 3L pebbles on his next turn. Sorry, something is... Um, okay, maybe I am not right here. I'm missing something. Yes, it's obviously difficult. It's obviously difficult puzzle. I will try a little bit more to solve this. So if Archie uses the strategy to take a gap of plus k, then on his next turn, turn, all players will have the same amount of pebbles. But this will not be the case if other players uses the strategy. Okay, I am I am losing the plot probably, but let me try it this way. So let me see what we have for Archie, what we have for Billy, and what we have for Charlie. If all full cycles were played and if somebody or even more players were using the strategy. So if just one player uses the strategy after full cycles, the amount of pebbles remain the same as without the strategy. So um, so the amount of pebbles can change only from strategy of other players. On their previous move. So after L full cycles, Archie will normally have M plus 3L pebbles turn on his turn. Um, So this my conclusion was actually wrong. This is true only if nobody or Archie makes the strategy. So after L now I will put big L because I use this small L for something else, but doesn't matter. The idea was probably wrong. So after L full cycles, big L, and if is Archie's turn, he will normally have m plus 3L pebbles. But if Billy took the strategy by K1, it will have plus 2K1 more. And if Charlie takes the strategy by gap K2, of course, K1 and K2 can now be 0. It will have this number of pebbles. But now I see something. If it's Billy's turn, Billy on his first turn actually has m plus, let's see this. On his first turn, Billy has m plus 1. On his next turn, Billy has m plus 4. Then m plus 7. So after L full cycles, if it's Billy's turn, Billy will have m plus 1 plus 3L, which is number of cycles, plus okay, maybe I needed to write this one for Archie. For Archie, this will be plus 2k if Billy plays. So let me put this as k2 if Billy plays. And this is if Charlie plays, I will say this as k3 as third player. And now if Billy has its turn after L full cycles, it will have m plus 1 plus 3L plus 2K1 if Archie had a strategy by gap K1, and plus K3 if Charlie had a strategy. And Charlie on his first turn had m plus 3. On his next turn he had m plus 6. So actually Charlie has m plus 3 plus 3l plus 2k1 if Archie had a strategy plus k2 if Billy had a strategy on its previous turn. So this was actually misleading numbers when we thought that Archie is getting more and more pebbles and Charlie is getting less and less. This is after one full cycle from the beginning, but when it's his turn, after L cycles, Archie will have less, the lowest number, m plus 3l. Billy will have by one more, m plus 1 plus 3l. And Charlie will have the most, m plus 3 plus 3l. So it seems that Charlie is in the best position here. I think that I'm close now, but it's really difficult to conclude everything because what happens now? So if after L cycles Archie in on his turn, he will need to choose some number. Let me call that number n. So Billy, so let me first see without strategy, without this, and this. Billy will need to choose a bigger number, n plus 2. So he will need to use at least 2 pebbles more, and it will have only one pebble more. And Charlie will need to use at least number n plus 2. So he will need to use four pebbles more, and it has only plus 3 more. Oh, I don't know. This is really confusing. It seems that without strategy, somehow that Archie is in good position because Archie has, after his first term, m minus 2. After that, he needed to choose the m minus 2. Billy had m minus 3. And Charlie had also m minus 3. This is 1 minus 4. 1 minus less here. And after the next term, after one full cycle, A is on m minus 5. And Billy is on m minus 6. And Charlie is on m minus 6. Like Billy and Charlie are always one pebble less than Archie after their turn. First, it seems that Archie is in the best position here. Okay, let me try to write this like this. So let me try to assume this. Without strategy, Archie will have m plus 3l pebbles. And it will need to choose number n. And so it hopes that it will have enough that m plus 3l is greater than or equal than 2n, because he needs to distribute 2n pebbles. But if Billy was using a strategy by k2 on his previous term, he will need to choose 2k more. and it will have 2k more. So as I already said, I can neglect this because strategy from Billy will not affect. Only strategy from Charlie will affect this, because now if Charlie wants to force Archie to fail, to lose the game, he needs to choose that although Archie will have m plus 3l plus k3, that he will lose because it will need to choose 2n plus 2k3, which will now not be enough. So what we'll have actually here? We have that 2n is less than or equal m plus 3l is less than 2n plus k3. But what does this mean? This means that if Archie will need to choose a number n, that if Archie will need to choose number n without strategy of other two players on their previous turn, that actually means that Archie was choosing number n minus 3 on his previous turn. So Archie was using number n minus 3 on his previous turn. Then Billy n minus 2, then Charlie n minus 1, and then Archie will need now to choose n. And that was actually enough on his previous turn, because we assume that he didn't lose before. And on his previous turn, turn, Archie had M plus 3 times L minus 1, but also plus maybe if there was strategy before. Let me say plus 2k2 prime plus k3 prime. And that was enough. That was greater than or equal 2 times n minus 3. So what does this mean? This means m plus 3l minus 3 plus 2k2 prime plus k3 prime greater than or equal to n minus 6 for that m plus 3l plus 2k2 prime plus k3 prime, which will be the number of pebbles for Archie on his next turn if other players are using the same strategy in the next cycle, will be greater than or equal than 2n minus 3. Okay. Here Billy had enough pebbles. Billy had enough pebbles. So, okay, I can't figure this out. It had enough pebbles on his previous turn. But this will maybe not be enough on the next turn. Because on the next term it will have -3 less. So 3 less if other two players doesn't change the strategy. Okay, maybe I need to think another way. Um, I will try a little bit more. Um, so I will open a new layer. Oh, sorry. So um, Archie, Billy, Charlie. We said that after L full circles and with Archie on turn, Archie will have M plus 3L pebbles plus K3 if previous player Charlie is using a strategy with gap K3 plus 2K2 if Billy on his previous turn was also using a strategy by gap K2. For Billy, this formula is M plus 1 plus 3L plus K1. Previous player was Archie, affecting by K1, and also if Charlie was affecting this was 2K3. And Charlie, after L full cycles and his turn, has M plus 3 plus 3L plus K2 effect of Billy in previous turn plus 2K1 effect of Archie on his previous turn. What I wanted to conclude actually. Hmm. So we already concluded that Archie can lose with help of Billy. Of Billy's this K3 on his previous turn. So Archie now needs to choose some number n, and it will lose if his number of pebbles m plus 3l plus k3 plus 2k2 is less than 2n, if it has no enough pebbles. But if Charlie now needs to choose n, that means then Charlie in his previous term actually has chosen n minus 1. And his number of pebbles at that turn was m plus 3 plus 3 times L minus 1, which was in the previous cycle. Of course, plus K2 prime strategy of Billy in the previous term, plus 2K1 prime strategy of Archie in the previous turn. But Archie could use that strategy if it had enough pebbles, if that number of pebbles was greater than or equal to 2 times n minus 1. So Archie can lose with n, if this is true. But that means that Charlie had it enough in the previous term. Okay, I'm not sure. Can I conclude something here? This is m plus 3 plus 3l minus 3. This actually cancels. Plus k2 prime plus 2k1 prime less than greater than or equal to n minus 2. So this means then m plus 3l m plus 3l minus 2n greater than or equal to minus 2 minus k2 prime minus 2k1 prime. And here we need m plus 3l minus 2n less than minus k3 minus 2k2, which means that we actually need minus 2 minus k2 prime minus 2k1 prime less than or minus k3 minus 2k2 times minus 1. This means that 2 plus k2 prime plus 2k1 prime greater than k3 plus 2k2, which means that Okay, maybe I lost the plot. Maybe I shall need to give up here. I had some ideas, but I was not able to connect them all together. The problem is that I'm somehow mixing strategies from one cycle with strategies from the previous cycle, and I cannot clearly conclude that. So the conclusion is that each player can affect the next player. But it needs enough pebbles for that. So Charlie in the previous cycle had this amount of pebbles. And if this is greater than this number, that he can choose n minus 1. And with that, it needs to achieve that Archie, when choosing n, will not have enough. So if we write this to n, we need that m plus 3l plus k3 plus 2k2 is less than 2n, and then 2n is less than or equal to m plus 3l plus k1 prime plus 2k1 prime plus 2. This is exactly this we need this inequality, and K3 is the number which was gap of Charlie, and then K3 shouldn't be too big. K3 should be less than or 2 plus K2 prime plus 2K1 prime minus 2K2. Okay. I hope that I give you some ideas, but I was not able to prove this, to find the strategy for neither players.